Welcome everyone to the A to Z speaker series, and we're very excited today to welcome Gary Atkinson, who is currently at UWE, the University of West England. Gary completed a Master's in Science degree in Physics at the University of Nottingham in 2003. When he graduated, he then moved to University of York and studied for his PhD in the Department of Computer Science. In 2007, Gary moved to Bristol to the University of West England Centre for Machine Vision, which is now part of the Bristol Robotics Laboratory, to work on face recognition and recognition research in collaboration with Imperial College London, and has since been promoted to Associate Professor and appointed Programme Leader for the Bachelor Engineering in Robotics in 2023. So if you haven't guessed it, Gary will talk to us about future careers in robotics, and we're very excited to welcome him today to lead on a presentation. Thank you very much, Gary.
Okay, thanks for that introduction. So the first thing I'll do is just share my presentation. So thanks for that introduction, and thanks everybody for listening to this short presentation. So I'm the current programme leader of the undergraduate course here at UWE, as we call it, University of West of England. So I'll talk to you today a little bit about what robotics is and where it's going, and in particular, what careers look like in the field of robotics. But to start with, what I would like to do is just talk a little bit about some of the perceptions of robotics, because it's robotics is a term that is quite evocative in many ways. People have different ideas about what it means. So a lot of people, if you just stopped people in the street and you said, "What do you think of when I say the word robotics?" They tend to think of perhaps one of three things. First of all, they might think about automation. For example, here's an image of obviously car being manufactured at a huge plant. Second, they might think about robot warfare, like Terminator or something like that. A third thing they might think about is hobbyist robots, things like toys and things like that. And these are obviously quite negative connotations, losing jobs, warfare. There's not exactly a negative connotation of toys, but it's not exactly a positive thing either. But and actually, the truth is, when you look at the reality, well, there is some truth in that. And I'm building up a career in robotics, and robotics is my life. But it's not my job to pretend that there aren't pitfalls and problems of the field of robotics. Okay. And if, for example, you came to do my program here, I wouldn't shy away from talking about some of the dangers that we might face in the future. But it's important to put everything into context, because there are also huge potential benefits to the individual and to humanity within this field. So let me now just balance the situation a little bit by introducing to you a few of the sort of positive developments. These are all based, these three images here are all based on little bits of research that we've done here in the Bristol Robotics Laboratory. So on the left there, what you're looking at is a weed in a like a field, like an agricultural field where it's for farming. And what happens a lot at the minute is, to get rid of the weeds in a field, is that people just spray the entire field with weed killer, which is not a very sustainable practice. So we've developed a system that has a tractor with a camera system on it that will detect the weeds, and then it will only spray the weed killer where it needs to spray it. Okay, so it's not something that people perhaps think of when you hear about robotics in the news, but this is the sort of example that I think can change the world for the better. You've also got a situation there in the middle. It's quite an amusing little story in a way, is that we developed a system that can extract an electrical current from urine. Okay, obviously a very sustainable practice if we can do that. It's not going to power a city, I'll be honest with you, but what it might do is it might power a light in a toilet in a remote part of the world. So again, it's not a world changer in this case, but it's a force for good. And then finally, we also have an aging population, especially in certain parts of the world. And robotics, we think, is one of the key technologies that we can use to help support an aging population when we might not have the resources to have, for example, nurses going to visit every 80-year-old or 90-year-old in their home every day. So robotic assistance is potentially making a big difference there. So yeah, like I said, I'm not going to shy away from some of the challenges that we might face, but it has to be put into context of all the huge benefits of the technologies being researched at the minute. So that's a bit about the background of what robotics is and what it can do. The other interesting thing about robotics for me, and one of the reasons why I like to working in the field, is it draws together so many different disciplines. So I'm from a background of pure sciences, actually, originally in physics is how I graduated, and then I did a degree a PhD in computer science. But you can look, if you look on the diagram on the right, for example, I won't talk about all of these in turn, but you can see that we've got the pure sciences here. We've got things like programming and computing. We need to think about the ethics, which of course relates to some of the other slides. We've got psychological aspects of it as well, legal aspects. So it brings together so many different fields, which is one of the reasons why it's such an exciting area to work at the moment. And then similarly, it has many application areas from home entertainment through to medicine. We talked about the healthcare already, security, space technology, and so on. And here in the BRL, it's almost like everybody I speak to, every new person that comes my way, seems to have a different background to everybody else that works here. So whereas my original background in physics, everybody had a degree in physics. Whereas here in computer science, sorry, here in robotics, you've got computer science, physics, maths, and so on. So that's one reason why it's interesting to work in the field. Now, I work specifically here at the University of the West of England. So this is the picture of the brand new engineering building. I'm not going to bore you with all the details about the building and all the students that we've got here. But if you choose to come to visit the University of West of England or to study here, you will have access to this brand new state-of-the-art facility, which is where most of the teaching takes place. And my office, which is where I'm sitting right now, is here in the Bristol Robotics Laboratory. So just a few screenshots there of people working on robotics. These robots, of course, humanoid robots that you can see there. That's sort of the futuristic vision of robots that's slowly coming into fruition. But of course, a robot could be anything from a humanoid robot all the way through to things like, maybe it's not so clear in the image, but here we have a robot arm, all the way through to, in many ways, a simple washing machine is a type of robot. Okay, so the word robot could mean many, many different things. And I'll talk a little bit more later about some of the latest trends in the field of robotics, but we'll just park that for a minute. Now, if you wanted to study in robotics, I'll tell you a few things about what to expect. So obviously, the next slides are going to be particularly related to the undergraduate program here at UWE, but of course, other universities might have similar or related ideas about what you would be studying if you move into the field. So the first thing about robotics is you can think of robotics as a sub-discipline of engineering. Okay, so a lot of the skills and the techniques that engineers in mechanical engineers or civil engineers need overlaps with robotics. Yeah, so obviously we all need similar mathematical skills, for example, or the teamwork skills. So what we like to do for some of our modules is to link together all of the engineering students, which would be, I think, about 500 students or something like that, and put them into groups to work on a big world engineering problem. So it could be about water sanitation and things like that. And what's quite nice about that is we see students from mechanical engineering bring in one particular set of ideas, and then someone from robotics, maybe a little bit more from a programming point of view or control theory, and then you have some mathematicians. So, and they all bring something different to the project. Another example, which is of a module which is a lot more closely related to robotics specifically, is in microcontroller applications. Okay, so control and control theory is a big part of the field of robotics. It's not just about switching a motor on and off, and there's lots more complexities and intricacies than that. And one thing that we do is we use these tiny little robots, and we can program these robots, got lots of sensors on it to detect if it's near a wall and things, and we have a little competition to navigate through this maze, because that brings together a lot of the skills that you need in the field, from electronics, sensors, and maybe some computer vision, um, path planning technologies as well, and more artificial intelligence, which is another thing I'll talk about a bit later. In fact, actually, not much later. I'll talk about it now, because here's another module which is about advanced. It's a bit of a long name, but this module is all about how we can use camera technology and computer vision to understand the world around us, or specifically get a computer to understand the world around us. And actually, a lot of the latest developments in artificial intelligence, which is starting to make news headlines, is actually originated in the field of computer vision. So what I've done here is I've just used a little fun example about recognizing my cats. So you can see here what we have is what's called a convolutional neural network, which is basically for the purpose of today, we'll call it a little bit of AI. That can some real world leading experts in the field have trained a network to classify between 1,000 different objects, random objects like chairs, tables, footballs, cups, things like that. And then what I do is I take what they've done and I use a technique called transfer learning, which then takes this really general application of AI and then it fine tunes it to one specific thing. So rather than having to use millions of images to train my network, I just use 100 or so, okay? So maybe 50 images of each of these cats, and then I retrain the network so now it can recognize a new image of a cat. Doesn't sound like the sort of thing that maybe you expect to do, to recognize cats if you're doing a degree in robotics. But the point is then you can apply this to more industrial settings, for example, to detect defects in manufactured components, or you can use the same technique to detect pedestrians for a driverless car, and many other things. Yeah. So what I like, that's my philosophy, is learn the techniques with something fun and then apply it to something serious. And then, of course, what we can do then is the final year is we can then take everything that we've learned and put it together for a final year project. So here's a few random examples of projects that people have done, often aligned with some of the work of myself or my colleagues at the BRL. So you can see this project was about using a similar technique to this with the cats, but for recognizing flowers. And she developed a tool that you can use a mobile phone camera, just walk around in the British countryside, and it will count the number of flowers of a different type. And then you could do that then every year. That wasn't part of this isn't part of the project now, but every year, if she wanted to, she could go out and do the same thing again. And then it would monitor whether or not the flowers are declining or increasing for that matter. And then this is a project that built together some control theory to control this little arm here. We've got a camera here, so also combine that with some computer vision to detect defects on carbon fiber components. And this project was a little bit about assistance of the elderly. And this project was about, I think it was for decontamination or something like that of a nuclear power plant. So lots of different applications using the techniques that you will learn about if you do a degree in robotics. And I often get asked, well, if I'm running an open day or something like that, I'm often asked where people go to when they finish. And that's actually quite a hard question. Well, it's a hard question to answer, and it's an easy question to answer because people go to so many different places, including places that you might expect, like Rolls-Royce or Airbus, especially where I work in Bristol is well known for aerospace sector. But also go to completely random places like Coca-Cola or Britvic, companies that aren't exactly known for robotics, but all of these have massive warehouses and massive factories, all of which with equipment that's got robotics, it needs control theory, it needs control engineers, it needs quality assurance. So that's why actually the catchment is huge if you work in robotics. It's also worth noting that we're signed up to GradLink, which is for international students in particular. Obviously, maybe if you go back home or you go to a different country after you graduate, you still need some support. So we've signed up to the extra support that you can get via GradLink. So you won't be on your own after you graduate. Now, I organised a couple of field trips of late. So just down the road from here, we've got National Composites Centre. So don't worry too much if you don't know what a composite is. You can Google that later. It's not integral to this talk. But this is basically a manufacturing and a research centre. So it uses lots of robotics, as you can see, for manufacturing process. And I also took my students to the Joint European Torus Reactor near Oxford. And we also went to the Oxford University Robotics Institute there. So nuclear fusion, as you may know, is believed to be the fuel of the future, but it's quite hard to get things right. And one of the reasons why it's hard to get nuclear fusion reactors working is because there is extreme environments. It's hotter in the fusion reactor than the surface of the sun. So you can't just stroll in there and do some repair or maintenance. Okay, so all of that needs to be robotics based. Okay, as for that matter, would a traditional nuclear fission reactor. Okay, you can't just stroll into a fission reactor either because of all the radioactivity. Yeah, so robotics in extreme environments, of which this is an example, is another big area that people are moving into when they graduate in robotics. Other examples might include space technology or conflicts, where you've got conflicts, like bomb disposal and things like that, like mine detection. We've done some work actually here for detecting mines in a marine environment. But it's sad that they're there, but the truth is that there are mines there, so we need to detect them and dispose of them. Funny enough, well, one of our graduates actually, he went there. So he worked there. So RACE is, as you can see, Remote Applications in Challenging Environments, which is affiliated with a fusion reactor, and he's working on these cool robots, things like that now, to enter places that you can't realistically put human operator. Just two case studies for people, just to give you two examples of what people have done after they graduate. So this is Sean. So he was actually my final year project student, and this is a snapshot of his final year project where he's classifying this material type. This is called a carbon fiber reinforced polymer surface. And this is like a repair of it. So he was just detecting different parts of this repair process. These should be concentric. So he was checking that. But then, perhaps more interesting to you is that since he graduated, he's had a couple of jobs. One was mapping, both related to underwater applications, I believe. So he's got this robot. He didn't build that. That's part of the company, but he's working on sensors for this robot so that when you put it underwater, for example, to explore wreckage, as in the case here, it can work out where it is, it can detect for damage, it can look for certain artifacts and things like that. Basically, it's exploring the subsea, which is actually another harsh environment for robotics to work in. So that's just two examples. But as I mentioned, many destinations that people can go to in robotics. Then I just want to talk to you a little bit, as we're nearing the end of this presentation now, about where the future trends are. This is another thing I get asked a lot about. What is the future of robotics? And you might divide your answer to that question into two. One relating to machine learning and AI, and one relating to everything else. Yeah. So we'll talk about machine learning and AI. If you're wondering what machine learning is, everyone will give you a slightly different definition of that. But my definition is that machine learning is the hard bit of AI. Okay, I'm sure there are people out there that might disagree with me on that, but really, machine learning is the bit that takes all the data in the world or in a database and then works out patterns from it, and then allows us to do what we want or extract information from that. AI is kind of that plus a few bits on the outside. Yeah, so machine learning and AI, you don't need me to tell you that AI is making a big impact in the world at the minute, and it will continue to make a bigger and bigger impact. Okay, we've not seen the end of it yet. And what I've done here, I've just listed a few bullet points about where the research is. So if you're interested in a career in the area, what you might end up working in. Okay, and some of it is perhaps obvious. For example, you might be working in hardware. Yeah, so if you're building a driverless car, you might be working on the software. Sorry, the hardware, the sensing technology, the actuators that drive the car, for example. That's pretty obvious. Everyone could probably guess that. But when I talk about sensing technologies, to a layman, that's not really necessarily clear what I'm talking about. The driverless car is a good example because the driverless car brings together lots of different sensors. So it will have a computer vision sensor, that is a camera, detected some complicated algorithm that extracts information from that. It might have an ultrasound sensor for something close up. It might have a LiDAR sensor. And improving these sensing technologies is one big area of research, but also understanding how to fuse the different modalities, as we say, is another big area. So we've got sensing and hardware, and things like path planning as well. So you might have a robot that needs to get from A to B. It might be able to move in a straight line, but it might not be able to do that. Traditional robotics, you would have to apply a set of rules so that the robot can then work out which is the best way to get from point A to point B. But in a more open environment, it's a lot more complicated than that. So when we're walking around a city centre, for example, we are constantly making decisions about the world around us. We see someone walking towards us. Do we cross them to the left or do we cross to the right? Or do we stop and let them pass by? They're things that we take for granted all the time because we're so used to doing it. But it's quite difficult to train a robot to do that just on a set of rules. And that's why AI is needed, and AI is making a big difference to that sort of thing. So a lot of the research at the minute, a lot of the job opportunities are about how we can take the world around us, which has been built for humans, and adapt the robots to work in that world. Yeah, because we've got this example here. I just borrowed this off the internet. This is just like a novelty bar where a robot makes your drinks. A bar, a pub, or something like that is designed for humans to work in, not robots. Okay, so if you want then a robot to work in, you have to adapt the robot to work in that particular environment, and that's one of the areas of research at the minute, how humans or how robots can be embedded into a human world, and also how they interact with each other as well is not a solved problem. And then perhaps it's also worth mentioning that big data, you often hear about big data or data science because now the world is so connected that there's a lot of big data available to make intelligent decisions, whether that's for business decisions, scientific decisions, and so on. So yeah, you won't be surprised to hear lots of career opportunities in machine learning and AI. And this is the best. If you're watching this and you're 17 or 18 years old or something like that, you have been born at the perfect time to get a career in machine learning or AI. Other areas are worth mentioning though as well. So I'm particularly interested in soft robotics. That's not my main area of expertise, but I'm interested in it because I see a lot of future potential. Now, soft robotics is just as its name suggests, it's robots that are soft. Okay, why would we want soft robotics? You may be asking. Well, to give you an example, if you want to pick up a glass, your fingertips are soft, aren't they? So when you pick up the glass, you can gradually sense that you're touching the glass and then pick it up gently. A traditional robot arm is made from like metal or something, and the gripper at the end of the arm is not soft. So it's quite difficult to train the robot to pick up a glass without breaking it in such circumstances. It's possible, but it's difficult. So soft robotics is the field of making sure that everything that the robot that parts of the robot are soft enough that it can interact a little bit more seamlessly with the world around it. And then people have taken that to the next level. So they're doing things like, this image at the bottom here with the man's arm. This is a wearable technology for someone who's maybe has an accident and is trying to rehabilitate and retrain his arm. He's lost a lot of strength in it. So we've got these soft robots, if you want to call them robots, that can help him to lift his arm again. And then this is another thing for a pair of trousers where it looks like a normal pair, well, normal-ish if you've got a weird fashion sense, pair of trousers. But actually, these are full of actuators that will allow the person to walk using less muscle power. So if you're elderly or if you had an accident, then it can get you back on your feet. Yeah, they can only increase. I mean, don't quote me on the figure, but I think it's something like maybe 10, 20, or 30% less power that you need to walk with these compared to without them, which doesn't sound much, but often that's the difference between being able to walk, not being able to walk. And then things like drones, of course, is another big area, and swarm robotics. Swarm robotics is about having lots of little robots or potentially big robots, lots of robots that interact with each other. So I already talked about human-robot interaction, but also robot-robot interaction is another big area of research at the moment. So what's my advice to you moving forward, other than to study robotics, especially on my program, which of course is the best program? So here's my 4 tips. The first tip: don't forget the basics. Okay, if you want to be good at robotics, you still need to be good at maths. Okay, and also get practicing coding. Okay, Python is generally slowly becoming the sort of standard language for robotics, but you could use C or MATLAB as well. So get learning coding if you've not already done it, and the more you practice, the better you'll become. Learning a programming language, just the same as using a different language, French or Spanish or whatever. The more you practice, the better you'll get. Second tip, and I have to admit, I struggle with this myself sometimes, is to keep up to date. It's so hard to keep up to date with the latest hardware and techniques out there, and even I struggle with it. But yeah, just keep an eye on the news, look at some of the latest papers that's being, excuse me, being published in the literature. Don't always trust what you see in the news, of course, because often you'll see something in the news that's going to change some research going to change the world. It doesn't happen. But try and keep up to date, and also the law as well will be changing a lot, I think, over the coming decades. And also talk to people about it. So visit universities and chat to people about what they're working on. You contact people on LinkedIn and things like that. There's a lot of rubbish on the internet, though, as well as a lot of great material. So just be careful where you get your sources. But my most important tip, there's a 4th tip, is the most important tip, and that is to play. Okay, just play with, robots, play with coding. Just decide what you want to write a code to do, and then do it. I used to use an example of writing code to animate a clock. Okay, just a bit of fun, just to play with it, and then you'll get better. That's it. Yeah, so final advice: play with robots. That's my top tip for the day. I hope you found that useful. I will wrap up the presentation there, but I do welcome any questions.
Gary, thank you so much. That was very, very interesting. Not only did you talk to us about careers in robotics, but you also talked about trousers of the future as well, which was very exciting. So thank you very much for your presentation. So this is the A to Z speaker series, and I do have the privilege of asking Gary Atkinson some questions about future careers in robotics. Gary is, of course, the program lead for robotics at University West of England, UE. So Gary, tell us a little bit more about robotics and potentially how you see it shaping the future of work and the types of jobs emerging as a result?
Yeah, so I think, a lot of people when they think about robotics and the job market, the first thing they think about is the loss of jobs, not the generation of jobs. And I kind of mentioned that in the presentation, and that is a challenge. But I think there are a lot of new jobs that for things that robots can do that previously haven't been done. So one of the examples I think of is what I mentioned in my presentation, which is the weed killer. Okay, that's something that's not taking anyone's job or anything like that. That's just a new thing that previously wasn't been done, hasn't been done before. And then another related area I think is in waste management. We all know there's too many people in the world. We all know there's too much waste in the world, and that somehow we need to deal with that. And the truth is that just putting your can in the recycling box, that's not going to save the world. Okay, it's just not going to happen. So in terms of like the job market, what I see is a lot of engineering jobs will be generated in building robots, building infrastructure to handle all this sort of thing autonomously. So you'll still get, for the time being, people collecting waste. But whereas previously what's happened is that's all being dumped into massive vats in a recycling centre, and the recycling material gets um, contaminated because actually different plastics they have to get recycled in different ways. That's quite difficult for humans to identify which plastic can go in this bin. I mean, we all know that from our own experience trying to recycle, I think. So things like building a machine that's got the right sensors, in this case, probably using hyperspectral camera technology that can pick out, okay, this belongs there, this belongs there. Okay. And like I said, the beauty of that is that's not a robot that's taking anybody's job. That's a new job for someone to build and design and maintain this robot that is then performing a really important job for the world, which at the moment is either not being done or not being done well. And I think to answer your question directly about where the jobs are going, it's things like control engineers. There'll be a lot of control engineers needed to code these robots, and also AI software developed so that the AI will be able to learn um, let's stick into this example for a minute. It's easy to understand visually. The robot can say, okay, I know what that is because I've seen lots of them before, so it can deal with that accordingly. That's just one example, but like I said, the funny thing about AI and robotics is a lot of the techniques that are developed for one application, like in waste management, only need to be tweaked a little bit before you can use it to forecast financial figures. So it might be that you're trying to work in business, but you learn my cat recognition system from the presentation, and then you adapt it a little bit. A little bit of a simplification from me there, but you understand.
Yeah, it's incredible though, isn't it? The potential reach of robotics, and actually, how much robotics is integrated in industries at the moment. You used some of the drinks companies as an example earlier on. So looking now at students in particular, and those that are interested in, pursuing careers in robotics, what kind of key skills should they start developing? I think you did mention coding. Are there any other technical and also soft skills that they should be looking to develop now, in order to pursue careers in robotics, do you think?
I think from a technical point of view, um, yeah, like I said, so, yeah, learning to go. I mean, Python would be the go-to place, and lots of terrific online tutorials about Python if you want to learn from scratch. And interestingly, these days as well, you can use things like ChatGPT to write code for you, and don't hesitate to do that because it's actually remarkable how good it is. But it will also make some terrible mistakes. So comparing your own code to what ChatGPT does is an interesting way to help improve your skills both at coding and in terms of um, understanding the capabilities of AI. So I'll do that, and also think about buying a robot, because you can find lots of affordable robots now online that you can purchase for like reasonable price. So it could be like a few £100 or whatever, or euros, whatever currency you have. Um, so for example, there's a robot called a Thymeo robot, which I use during our open days, which is it's just like a two-wheeled. I should have had one here. It's like just a two-wheeled robot, and then with lots of sensors on it, and you can code it to, for example, navigate around the desk. That's what I do. I have it moving around my desk, and then it stops when it gets to the end of my desk. But there's different ways to code that. There's like a school version of it where a lot of the coding's been done for you, and you just putting blocks together. So if you're sort of 14 years old or 13 years old, you can have a play with it. But also you can interface it to Python libraries. So, if you're already at university, it's a good thing to play with. So that's got a Thymeo robot. But there's lots of examples if you just look online. As far, so yeah,
No, no, I was just going to go on to the next question, but you carry on.
I was just going to, as far as soft skills is concerned, I think, making sure you can work in a team, because and that's kind of a cliched answer, I know, but one of the things that we do, as I mentioned earlier, in the first year of our undergraduate program, is we get engineers from all disciplines together. So we get mechanical engineers working together with roboticists and civil engineers, because they all bring something a little bit different. And there's so much to know now. There's so much to know about, well, especially about AI, but other things as well, that no one person can possibly be expected to know all of it. So you have to get used to working with others, both within robotics and in engineering, and arguably outside of engineering. So.
Yeah, fantastic. And I guess with any kind of teamwork, communication skills are also very, very important as well. Okay, looking now at parents and our parents' audience in particular. Now, obviously, you mentioned investing perhaps in a robot for their child to explore and develop skills and experiment a little bit. Are there any specific subjects or courses or activities that you would recommend for parents to introduce to their children, quite early on, or, as they start making decisions about their future career?
Yeah, I mean, the good thing these days is that I mean, I have a daughter who's 7,
Oh,
and I've already bought her a little dinosaur robot that you can control with a few buttons to tell it when to go. And I think I don't think we should enforce 7-year-olds to study this, but it's good. The good thing about robotics is it's good fun. And
mm.
if you don't enjoy doing that sort of thing, then it's probably not for you. Um, but I think if you do enjoy playing with that, um, I think, yeah, playing with. I mean, I loathe to recommend specific products, although I could possibly send that offline if it's useful. Um, but yeah, so, some of the good quality ones, which I could recommend offline, are they come with their own tutorials. Also, MATLAB is also a good resource if you're quite new to coding, or if that's not exactly your main skill. MATLAB is an easy programming language to get into, and then there's a version called Octave, which is free, so you can look at that.
Okay, fantastic. What I might do is ask you to provide some links offline that we can share with parents. Would be
Mhm.
really, really valuable. Um, yes, I was going to ask about, any apps or any kind of computer software that they could maybe introduce to spark curiosity and maybe not enforce robotics on their child, but just giving them exposure, I think, early exposure to a very significant field of the future.
Yeah, I think that the Thymeo robot that I mentioned before is a good option for that, because it's very affordable,
Mm.
for one thing, and for younger children, like I said, the good thing about that is it has like a drag and drop sort of interface, so that rather than having to code the robot at a low level to say, right, actuate motors for 10 seconds and then stop when one sensor says, you don't need to worry about that. You can just drag and drop, so that then a younger child can see how the control software is put together, even though they won't perhaps think of it as a control software. That's quite a grown-up term, but they'll just see it as a system which the robot is able to use to understand the world around it. And then as they get more advanced, then they can start taking some of these blocks and then looking inside that block and then maybe making changes. So you're just getting that little bit deeper control over it. The other thing that perhaps for well children, but older kids, so maybe more like sort of if you're sort of 17 or 18-year-old and you're getting close to applying, or maybe you are applying for university, is to have a look at a place called RoboFlow, which is a very well-known website within the field of robotics and beyond. And this is where you can train your own neural networks. So I gave the example of the cat. I did that myself from scratch in MATLAB. But if I wanted to, I could have used that website to upload images, and then I'd need to know a little bit more about how neural networks work compared to the really low level stuff. But I don't need to be a world leading expert in coding a net in order to get that working. So definitely worth people looking at RoboFlow. It's a really brilliant website.
Okay, fantastic. And I guess the final question I have for you, and it will just be, I guess, summarizing what you've already said to us, really. But if you had one key piece of advice for parents, what would it be?
I think if it's advice for parents of people 16 or under, my advice would be to get fun toys and let the kids just do what they want with them. Don't have a particular end goal in mind, because the best way that you can get into this field is not to say, right, I'm going to achieve A within the next year and B within 5 years, because it's so rapidly changing. That's not the way to go. For me, the way to get into it is just to play around with it, and then eventually ideas come your way. Because we also have PhD students here in the BRL working in robotics, and when they're starting out, some of them have a definite project, so they're restricted to reach certain goals. But sometimes I say to them, look, just look at some of what other people have done, and then you do something similar, and you'll probably find something new, something along the way that no one's tried before.
Okay, that's fantastic. Listen, you're doing incredible work over there at UE, University of West of England in Bristol. So thank you very much for sharing your knowledge, for sharing information about, what you currently offer there, but equally, what parents can do to support their children and to kind of have meaningful conversations about robotics in the future as well. So
Mm.
thank you very much for your time.
Well, thank you very much for inviting me.